Good morning everyone, good morning ladies, good morning gentlemen. It's great to see so many people here today at the Embedded World for the RISC-V Roadshow. My name is Florian, I'm working for Andes Technology. We are a RISC-V IP company, and today I want to give you a short overview why RISC-V is so cool and how Andes can help you by implementing it. Let's start with IoT. What is it anyway? IoT, there are so many words out. IoT basically is everything where you put a processor somewhere in the edge. If you are looking, mobile phones, they have thousands of processors. One processor for the touch screen, one processor for the Wi-Fi, and so on. If you're looking for the Amazon Echo, for example, there are some processors inside and it's IoT. Why? Because they are doing some keyword spotting. They are looking for the wake-up command and then using all the high processing power. So all of this stuff is IoT. Why do you should choose RISC-V for AIoT? What is the cool thing about RISC-V and IoT? Well, RISC-V is an open standard, so everyone can use it and everyone can make his own implementation. You're welcome to take the implementation from Andes, but of course you also can use from other people. The second thing is RISC-V is a modular yet stable architecture. That means you can combine the CPU, you can combine different things and make the CPU specific for your use case. One more thing, it has the DSA, domain-specific architecture, which allows you to make your own instruction into your RISC-V core. So that is a cool thing because you can have a standard RISC-V CPU and then bring your own custom instruction and differentiate from the market. And last but not least, RISC-V is supported by world-leading companies, so it's not only Andes doing it, there are many people here. There are many people in the United States like NVIDIA, Google, Western Digital, just to name a few. All of this supporting RISC-V, and that is good for the ecosystem because it will grow it and make it more popular. Let's give you a very short and brief overview about Andes Technology. We are a Taiwanese company, so we are based in Taiwan. We are 15 years on the market. We had over 200 licenses worldwide, and since 2018 our customers shipping every year over 1 billion cores. Andes has looked closely on RISC-V when it was started with the foundation around 2015, and we found it's very similar to our own architecture, so we are decided to join, and Andes is going very strong in RISC-V. We are supporting, we are founding member. We're an open source maintainer and contributor like U-Boot, LLVM, GCC and all this stuff. Our engineers really try to upstream and make life more easier for everyone. The product Andes is offering, mainly CPU cores. On top of CPU cores, Andes has some nice architecture extension, which you can do with RISC-V, which is the cool thing about RISC-V. And then we are also offering some bare metal, so you can have an easy and fast starting and programming. We do have an Andes side, which is an Eclipse-based IDE for programming. And of course, we are also offering some software stack, so you can have a faster time to market by having already the drivers ready, by having a FreeRTOS already ported, or even a Linux BSP if you want. Let me show you some of our differentiation we are having with others. For example, we have some performance extensions. We have extension we are calling Codense. Codense helps you to have a smaller code size compared to the standard RISC-V compiler. And then, of course, for the domain-specific architecture, which allows you to have your own instruction into the core, we have a framework which allows you to program this very easy. It's kind of Arduino style, if you want to say like that. For the cores, I show you a quick glance on our roadmap. So we are starting with a 2-stage, the N22. Then we are having our 5-stage pipeline, and the 8-stage pipeline is made to run Linux. The smallest core we are having is a 2-stage pipeline core. You can highly configure this. That means you can add things, you can change the multiplier to be very fast but have a high gate count, or you can make it a little bit slower but smaller gate count. Bus interface, you have AHP Lite, you have optional iCache memory, and this controller is also available in our Free Start program. Sorry, maybe I should not move so much. The Free Start program is nice for universities or students who just want to get started. You can download it and start directly programming a RISC-V core or just seeing how you can modify it. What we are also delivering on top of the core is a platform. The platform is mainly so you don't need to reinvent the wheel all the time new. We give you some general purpose IOs, we give you some SPI, UART and all this stuff so you can use it together with our core and focus on your special distinguished, on your special secret source, what makes you unique or your SoC unique from others. The end is RISC-V 25 series. To give you a short overview, it's a 5-stage pipeline. We do have optional instruction and data caches as well as instruction and data local memories. All of this can be protected by ECC, especially if you, like some of our customers, want to go to a 7 nanometer process or something like this. ECC can make a big difference. Our bus interface, just for your reference, it's AHB or AXI, so you can switch it. And it has some nice tools which make it very easy for you. Anything else? No. So again, for the core, the M25, and this is also offering a platform, again with the GPIOs. We have some BAS metrics, some DMI if you want to use. So the thing is, if you have your hardware accelerator, for example, you can connect it to the green things, so you don't need to spend time with all the other things. You can take the NDIS core with the RISC-V debug specs module inside and everything. It's working out of the box, and you focus on your hardware accelerator to make your AI IoT chip for the Internet of Things. What we have announced last year and what is now coming is the A27 series and the A45 series. If you have some questions for this, please feel free to ask me later. We don't have enough time to go through this. Basically, it's an advanced core, so it's ranging for example, Linux running in smartphones up to 4 core or more. One of the things we have in our course is a DSP extension that is in RISC-V officially the P extension that is a SIMD instruction set kind of. It's single instruction on multiple data. So you have one instruction, it's taking general purpose registers and is performing different operations on these registers assuming different values. So you can have in one register 4 different data, only 2 different or only one data set. The cool thing about the DSP extension is that it can help you to speed up certain points. For example, if we are starting with an MP3, using the DSP extension, you can speed it up by 2 times. If you're going more to the CIFAR image classification, that's where you are putting an image inside the CPU and then the CPU tells you what it sees. Is it a pig? Is it a duck? Is it a dog? Then you can speed this up by 11 times. Why is this so important? Because in the AIoT, you want to save power. So if the CPU can do it faster, you have 2 possibilities. The CPU can sleep for the rest and save power, or you can use a lower clock speed for your CPU and have the same data throughput and therefore also save power again. The next cool thing NDIS is offering is the NDIS custom extension. That is actually a framework which allows you very easily to bring your custom instructions into our CPU. For example, if you make a checksum, if you want to see that all your message is correct, you can use a custom extension and you can speed up the whole process by 162 times. Now imagine if you have an AIoT device and you have a few jobs, you can speed up like this, how much power you can save, and then you understand why some of these AIoT devices can operate, for example, on a coin cell battery. How is our NDIS custom extension working? Let me walk through it very quickly. So first, NDIS is giving you the RTL code for the CPU, some simulator for the CPU, and also disassembler, assembler. Then our tool Copilot, the framework is coming, and you tell our tool which function you want to have. That might be some Verilog code, some C code description for how the instruction should behave, and you give some attributes like is it a scalar or a vector, should it finish in the background. You also can use wide operands like 512-bit registers on a 32-bit CPU, for example. And Copilot then takes this code and integrates it with the CPU pipeline. So that allows you to save a lot of time. And most important, it also generates some test cases. If you are making a commercial available CPU, that's what you want to have, test cases to make sure there is no other problem or bug introduced into your CPU design with this. Okay, we are almost at the end. Please bear with me. In Andes, we are also offering some Andes sites. That is our graphical user interface for writing or developing programs. Our Andes interface, as you can see, comes with some virtual simulator and also with the hardware platform, so you can write your software, your application, and you can simulate it on the FPGA platform or directly in a virtual simulator. That allows your engineers, the software department, to start already writing code, while the hardware department still is defining the specification of the code. And this has also some nice features like a managed build system, an analyzing tool where you can see the bottleneck in your software flow, optimized tool chains, of course, and also flashing, for example. Set up some pictures from our code size. For example, in the middle upper part, you see how the profiling analysis is working. So with this, you can see where in your program are the bottlenecks and where you need the most CPU time for calculation. And then you could go and write an optimized instruction to speed this up and save more power. And as like I said before, we are starting from our Andes side, the graphical user interface. We are offering the hardware. We have different FPGA boards to give you a fast and quick head start. Our board is also qualified for the Amazon Web Service, so you can take it, put a free RTOS on it and connect to the Amazon Web Service, for example. We also provide you some debugging hardware. And then last but not least, the software, which is ranging from bare metal, where you have programming examples, how you really can access the GPIOs, the watchdog timer or so, over real-time operating systems, not only FreeRTOS, but also ThreadX or others, and up to Linux, where we give you the whole BSP. Well, then just to show you the ecosystem, like I said, Andes is really providing you everything, but the ecosystem, and that's the great thing about RISC-V, allows you also to use other people. For example, you will see you can use Andes for debugging, but you can also use Sega or IAR, good partners from us. You have different operating systems, for example ThreadX, but also LEOS from China. Then we have security, different partners we are working with, Hex5, SecureIC. So RISC-V, that is really the cool thing. It's one company like Andes, but the whole ecosystem are many companies. We are all working together, and together you have a very unique solution and you have very powerful tools which you can leverage. Okay, to the summary, AIoT requires higher performance with low power, and that's where Andes really can help you make a difference. We are having leading PPA, we are having good tool chains, so please come to us, find us here at Embedded World. And yeah, we are the experts, or one of the experts for RISC-V, and we would be happy if you want to use our core for your next design. Thank you very much, vielen Dank.